This will be a quick demonstration of my MATLAB project. I've developed a rocker or projectile motion simulator which gets inputs from the user and plots a graph based on the chosen variables. Now let's run the program. At the start of the program, the title of the project is displayed in the command window, shortly followed by context about the program and how the user is intended to go through it. So trying to get as close to the goal height and distance as possible. Once the user has read this, they'll be given a yes or no option if they would like to proceed with the simulation. As you can see, error handling is applied, so the user must only input Y or N. The randomly generated goal height and distances are then displayed, which leads us to the section where the user is asked to input variables for the launch angle, speed, and gravity. These all have error handling applied so that the user can only input floats or integers that work within the context, so no strings or negative values. The variables used to calculate the trajectory are then displayed alongside the randomly generated goals for peak height and horizontal distance. Then the achieved height, horizontal distance, and their differences to the goals are displayed, and a performance evaluation is shown depending on the size of the difference. Here it says needs improvement, try adjusting angle or speed next time. This means that the difference between the peak height and goal height and the horizontal distance and goal horizontal distance was greater than 60 meters for both of them. If it was less, it would have a more positive output. Finally, the user is asked if they want to see the plotted figure, which we will say yes to. This will then display the animated projectile motion in a generated figure in terms of time points, and the final graph will then be displayed afterwards. On this figure, the goals and achieved distances and heights are displayed alongside the motion. As you can see here, the goal height compared to the achieved height is significantly higher. Meanwhile, the achieved distance is significantly further than which was required. And we can zoom in or drag it if we want to do that. Then closing this, the user is then asked if they want to repeat the simulation. If yes, the program is looped. If no, the simulation ends. And I will say no or N. And that's the end of the demonstration.